Hi everyone, welcome to e-learning. So today we're going to be doing some natural sciences. Our concept for term 2 is matter and materials. Now you're going to be learning in this video on the properties of materials. Then I did two other videos, one on matter and materials, that's the different types you get, and lastly acids and bases. Now it's important to know the properties of materials because you need to know how one material is distinguished or different from another type. Now, you need to know, you learned in other grades, what is matter. Basically, you know that it is everything around us. It comes in three forms, which is solid, liquid, and gases, and each has its own property. So, matter, has mass and it has density and it occupies space and it's made up of tiny particles. And these particles are made up of atoms, and the atoms combine to form molecules. Now, all of these atoms and molecules, they basically are constantly moving. So that means they're in a state of energy and they move very, very fast. So we can measure matter with mass, volume, and density. Now, density basically is a measure of the compactness of matter. Uh, and the way that it is compressed together. So that means that it's like really thick, like petrol is dense, because all the molecules and the atoms are densely, tightly compact next to each other. Now, matter can change from one form to another through physical and chemical changes. But through any of these changes, matter is still conserved. It means that it is just changing from one form to another. It's not going anywhere. Right. So, from the periodic table, you knew that materials are classified into metals, non-metals, and semi-metals. So let's look at the characteristics of metals. We know that metals are ductile. That means it can be stretched into thin wires. They're shiny and they are malleable. So they can be bent and flattened into thin sheets without breaking. Right, we also know that metals are good conductors of electricity and heat, and also we know that mercury is a metal, but it is not ductile nor is it malleable. It just basically has high melting and boiling points. And we're going to do melting and boiling points later on in this video. Now let's look at nonmetals. So nonmetals are basically poor conductors of heat and electricity. That means that heat and electricity doesn't go through them. They're non-magnetic and they cannot be stretched out. They have low melting points and they are gases at room temperature. Also, they are insulators like plastic and wood and stuff like that. Then we get semi-metals. So semi-metals are found in the periodic table. They're found between metals and non-metals. They're light and strong and they can carry data over long distances. They're solid and shiny, but they are brittle. They're semiconductors of electricity, and they are made up of glass, cell phones, computers, radios, and optical fibers. They're basically used in electronics and also in rewritable DVDs. Now, if we want to look at example properties of metals and nonmetals, if you look this, basically, if you look at the metal in the first picture, you're going to look at the state of matter. Now, that is mercury, and you can see that it is in a liquid form and it's classified as a metal. Then we get non-metals like in the glass jar. So it could be either a gas or a liquid or also a solid. Solid would be a wooden table or a the glass jar that you see. Then in the picture below where you see good conductors and poor conductors. So let's look at the property of conduction of electricity. So in this circuit, you see that there's a nail. So the nail completes the circuit. So it acts as a switch. And the light bulb glows because the metal, the nail, is a good conductor of electricity. But if we look at the poor conductor of electricity, which is a wooden stick under non-metals, you see that the light bulb doesn't light up That's because wood is not a good conductor of electricity, so it's regarded as a non-metal. Now, let's look on the right-hand side. We can see the pot boiling. So the property we're looking at is the state of matter is conduction of heat. So we can see that the pot is a metal, so it is a good conductor of heat because it's allowing the water to boil under heat. Then we look at the poor conductor of heat. So we could see that the plug is has a metal on it, but it is surrounded by plastic. So that means it has the carrying case is plastic, so it's a good insulator. That means it's not a good conductor of electricity or heat. It's a good conductor. It's a good insulator. Okay, then we're looking at magnetism. So we can see that the cobalt or the iron are good magnetic metals that they attract each other. And the non-metal, you could see on the right-hand side where we have that little block, looks like cheese, maybe butter. And if we put some a metal against it, it's not going to attract it. Even the glass, it's not going to attract to it. Then we look at the appearance of metals. They're shiny, and non-metals are basically dull. So let's continue. If we look at these objects, we can see that they're made up of different materials. So here we have a building that's made up of concrete and block and steel. In the frying pan, one we have substance in it. I'm not sure what it looks like. Maybe fried chicken. So the metal saucepan is made out of metal. Then we have a little blouse, it's made out of cotton, and we have rubber. So let's look at the properties of materials. One, it can be flexible. So if we look here, we can see that the rubber hose is flexible. Then strong, the building is strong. Shiny and dull, we can see the frying pan can be either shiny or dull. Colored, we can see the top is colored, and stretchy or rigid. So the rubber hose can also be stretchy. Rigid, we would say that rigid means something that it cannot move. So I'll leave that up for you to decide. What do you think is rigid in this picture, in figure 4? Now let's look at the properties of materials. So there's different types of properties. So we have they're strong, it's strength. Strength basically means that it can withstand force without breaking. Examples of these are steel, which is very strong, and steel can withstand tension. That means um, it does not it cannot move, so we say that it has tensile strength. Whereas concrete basically has compressive strength because concrete can basically expand and contract with heat. Then we can say that properties of materials, they're flexible, so it can bend without breaking. Examples of those are rubber bands and car tires. Then the third property is thermal conductivity. That means it has the ability to conduct heat. They're good conductors of electricity. Examples of these are metals. And then thermal conductivity that are poor conductors of heat are insulators, which are wool and plastic. Now, if we look at the saucepan, the good conductor of heat is basically the boiling in this figure is where the water goes into the pot. Then the poor conductor is the handle because you can hold it while it is on the stove and you won't get burned. So the handle is made out of plastic, which is a poor conductor of um, heat. So we call it a thermal insulator. And a thermal conductivity is basically heat conductivity. That means it allows heat to pass through it. Then we look at electrical conductivity. It is the ability of electricity to pass through it. So good conductors are metals and poor conductors, which are insulators, are plastics and wood. Now, materials that allow electricity to move are basically called electrical conductors, and materials that do not allow electricity to move them through it are called electrical insulators. Then we have boiling and melting points. Now, in previous grades, you learned that matter existed as a solid, a liquid, and a gas. So in a solid, all the particles were compacted together. In a liquid, all the particles were loose. And in a gas, they were free. They were able to move. They were not confined to a specific space. Okay, so here we can see that the melting point, the properties of a melting point, it basically turns a solid into a liquid when it is heated. Boiling point, the liquid turns into a gas. So for example, when water melts at 0 degrees and it boils at 100 degrees Celsius. So in your class, you can do an experiment to see measure the time and you see how long it takes for water to boil. And it will boil at 100 degrees Celsius, and then you must check if it remains constant at that temperature. So when ice melts, it changes from solid to a liquid, and it does this at 0 degrees Celsius. We call this the melting point of ice. The boiling point of water is 100 degrees Celsius. So we're going to look at another, okay, let's focus. So around 0 degrees or 100 degrees, we say that because these are, now we look at the 0 degrees when you say it's melting point, and you look at 100 degrees and you say it's boiling point. But sometimes in different conditions, it's not always identical. So you can't always say that it's gonna melt at 0 degrees Celsius or it's gonna boil at 100 degrees Celsius, because you have to take the context, the environment that's surrounding the boiling point and the melting point. Now, things that cause is the boiling point and the melting point to differ is pressure, atmospheric pressure. It also could be impurities in the environment, like say in impurities in the chemicals, like for example in the water. Maybe in that period they had put more chlorine into water, so it's going to affect the boiling point. Or in, like for example, the boiling point of water could be 96 degrees Celsius in Johannesburg because the atmospheric pressure there is lower. Now, to melt or ice, you need energy. Okay, so when you're going to melt ice, you're going to add energy to raise the temperature to melt it. And when you're going to freeze it, that means you're going to take out energy. So you're going to remove energy until it starts freezing. So it's important to know this, because in the exams they can ask you what causes melting point and boiling point. And then you're going to say when you want to melt something, you're going to add energy. But when you want to freeze something, you're going to decrease the energy. That means you're going to remove the energy from it. So if you look at this diagram here, it's in the picture, you have solid ice. It requires energy to be melted. But when I have it in liquid and I want to freeze it, you need to release energy so it can be frozen. Also here in boiling, if we have the liquid, in the process of boiling point, we add energy, and then we want to melt it, we release energy. Now, other properties of matter is solubility and density. Solubility means that it can dissolve in a substance, and density is mass over volume. Now, materials that are used, you can look at the properties of the examples and the cases where you can use it. So you can pause the video and you can write it down to learn for exams. And here is a chart for you that you can look, go through it. It's a mind map that helps you to understand it. And once you do that, you'd be good for exams. Right, don't forget to like and subscribe. Hope you liked the video. See you in my next video. Have a lovely day, everyone. Bye.